What is going on, everyone? Welcome back. This is Turfgrass Pest Management, Chapter 6, Weeds of Turfgrass. This chapter is pretty dense. Just to clarify, this is for Category 3A in Michigan, Turfgrass Pest Management. We're following that book, but this content's probably still relative if you're studying for turfgrass in your area. The main difference is probably going to be in this portion and laws, but in this portion is the weeds that we're targeting. So majority of these weeds you're going to find in the Midwest, East Coast, a little bit further west, maybe as far as Missouri, things like that. Once you get further south, you're going to have probably different weeds, different grass types, things like that. But the concepts of pest management are still the same. So this is a very dense chapter. There's like 46 slides or something like that. So it's going to take some time. But if you're new here, hi, I'm Austin Douglas. I'm the owner of Elevate Applicate, and this is my little side project. Just trying to teach and provide information to pesticide applicators entering this industry, trying to help you guys be able to pass your exams with confidence. I know what it's like. Been there, done that. Not fun taking these exams. But if I can do my part and make this a little bit easier, help you understand the content, that's the goal, right? Just to help you guys get through this and enter the industry, because we really do need people to enter this industry. So without further ado, let's dive in. I'm actually going to put myself here. There we go. All right. So what are the objectives of this chapter? Well, we want to be able to describe weed biology and define the difference between what a monocot is and a dicot, describe the development stages of weeds, list the difference between annual, biennial, and perennial weeds, identify and describe the major turfgrass weeds in Michigan, describe how to manage weeds in turfgrass, explain how herbicides are used to control weeds, their effectiveness based on plant characteristics, describe how herbicide action is affected by weather, and identify how to correct herbicide application mistakes. So now that we have the objectives, now we can get to learning. All right. So I'm actually going to come back into this one. Weeds are a human designation. This is not a botanical one, right? In botany, in the world, weeds don't exist in nature. Okay, they're just plants doing what plants do. They grow. But humans have designated certain plants to be weeds. And they're only weeds because they interfere with the intended use of a site. Aesthetics in our lawns, health and safety concerns like poison ivy, vines climbing up utility poles, trees bringing down trees, and then playability in sports fields, right? If you had a professional field that was filled with weeds, it wouldn't look too great on TV. And it would probably affect the game, right? But it's also determined based on the location, the site used, and it's determined what's considered to be desirable and undesirable weeds, because in certain situations, weeds are desirable. And I will show you that in pictures later in this. Certain weeds can be desirable. Once established, most weeds can outcompete turf. And so our goal as turfgrass applicators is to have healthy stands of turf and not allow these weeds to take over. And just for the record, some annual weeds can produce 100,000 to 250,000 seeds in a single season. That is immense. So you can see how quickly they can outcompete. Grass does not produce seeds like that, but certain weeds definitely do. So let's talk about weed biology, okay? Weeds can be divided into two physiological groups, this is a hard one, monocotyledons and dicotyledons. In simple words, we're going to use monocots and dicots. Unless you're talking to like a biology major, a botany major, a horticulture major, they might say those long words, but regular folk like you and me, we're probably going to say monocots and dicots. An example of some monocots would be crabgrass, foxtail, yellow nutsedge, wild garlic. They have parallel veins, right? Your turfgrass in general is going to be a monocot. Monocots are mainly at ground level, which makes them somewhat difficult to control because they're mixed in with the turf. And then only in Michigan, only non-woody or herbaceous monocots exist. And also, fun fact, if you didn't know this, palm trees are actually monocots. They're not dicots. All trees are dicots except for palm trees. So let's talk about some weed biology, right? Both herbaceous and woody dicots are in Michigan. Dicots have a network of small leaf veins originating from the main vein that divides the leaf. Many families of dicots exist: thistles, dandelions, mustard, wild carrot, morning glory, poison ivy. I mean, there's so many different types of weeds. But here's a good example of what a dicot is. If you look at that leaf, the leaf on the bottom, you'll see that there's a center vein, and then you'll also see that there's a network of veins that come off of it. If it was a monocot, these veins would just run parallel straight up. So when you look at a blade of grass, you'll notice those veins just run straight up. Okay, so all broadleaf plants have above ground growing points. Some have underground growing points, right? Like stolons, like rhizomes, certain types of roots. But usually they all have a very strong taproot. If you ever try to pull out a dandelion, they got a strong taproot. Thistles, extremely strong taproot. So good indications that you're dealing with a broadleaf weed. So the 4 stages of development, this is one of the objectives that you're supposed to learn. We have seedlings, which are newly emerged immature plants. They're very tender, very vulnerable, and they can be stressed out super easily. They can also be managed super easily. We have the vegetative stage, which rapidly produces stems, roots, and foliage. They have a large uptake of water nutrients. I was supposed to say uptake, not update. Large uptake of water and nutrients when they're in a rapid growth state makes them really susceptible to herbicides, if you didn't know that. Then there's also the seed production stage. That's where the energy is directed into the seed production, whether that be flowers or actually producing the seeds. Water and nutrient uptake is relatively slow at that point, but what they do uptake is mainly directed right to the fruit, right to the flowers or the seed structures. Once weeds reach a maturity level, there's little to no movement of water, nutrients, or energy. And that makes them kind of weak and not very difficult, but more difficult to control with herbicides and chemical measures, because most herbicides rely on that vigorous growth state. When a plant slows down, the mode of action with herbicides tends to slow down with it. So weed biology continued. There's a lot of this one. So the development stages affects the responsive management tactics, right? An example would be an unestablished seed can very easily be eliminated through a cultural, mechanical, or chemical method. Let's take, for example, this little guy growing in this crack right here. You could just squirt that guy with some Roundup, or you could just pull it out, right? It's pretty small. It'll be very easily dealt with. Now, as pesticide applicators, we're probably not going to go out there and hand pull weeds all day long. It's just not effective, not cost effective, and I don't think customers want to pay that much money for it. But in a chemical aspect, just a quick spray, it's done. An example of plants in vegetative stages will uptake herbicides a lot more quickly. So if you ever pay attention to when you apply an herbicide to the exact same plant, whether you do it in the spring, early summer, late summer, or fall, you'll notice how it uptakes very, very differently. In my profession, I deal with poison ivy left and right, and I noticed that in late spring, early summer, it rapidly kills the plant because they're in rapid growth stages. They're in a vegetative state, right? Vegetation growth state. Once it dies down into late summer, fall, it takes a little bit longer for that herbicide to work. The plants aren't uptaking as much. They're going dormant for the season, etc. There's 3 distinctive weed types based on time to complete a life cycle. So again, this is another objective for you to know. We have annual weeds. Those live 1 year and then they die. That would be, examples would be prostrate, knotweed, foxtail, crabgrass. Those are going to be your summer annuals. Chickweed, annual bluegrass, shepherd's purse. Those are your winter annuals. Then we have a biennial, which their life cycle takes 2 years. Basically, the first year is just in development, and then the second year they reach seeds. Those are going to be your Queen Anne's lace, otherwise known as wild carrot, your bull thistles. And then we have perennial weeds, which come back every year or more than 2 years. It might not be every year, but more than 2 years. They're most persistent and difficult to manage. Yes and no. There's herbicides that can kill them quite well. They reproduce by seed or structures below ground called propagules, which those could be rhizomes, stolons, bulbs, or tubers. They store energy in the root system over winter and regrow in the spring. And managing perennials requires killing the underground systems of a plant. So you have to kill the roots. If you don't kill the roots or the rhizomes or the stolons or the bulbs or the tubers, they're going to survive and they're going to come back. So that tells you right there, ding, 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 that you need a systemic herbicide to take care of perennial-like plants. We also have cool season plants, another way to discern them. They grow best in the spring and the fall, and they generally go pretty dormant in hot, dry conditions. These are going to be your winter annuals and some perennials. Warm season plants, they're dormant or they wait to germinate until about May or June here in Michigan. Those would be like your Bermuda grass, your crabgrass, goosegrass, otherwise known as quack grass. And then let's talk about how are you going to identify weeds in the field? What tools can you use? Okay, there's a lot of field guides out there. There's websites, there's identification books, extension bulletins, and this book wasn't written at the time, but now there's phone apps that you can just snap pictures and it'll identify the plant. Picture This is one of them that's very, very common. I think they have a subscription model for a year. I don't know what it costs, but it is fairly accurate. Now there are some, might give you some options and you have to select the closest one, but it really, really does help you out in the field. There's also the ability to submit lab samples. It's best if you can provide the whole plant in a lab sample. Generally, you want to put it in a sealed plastic container or, in between, two pieces of cardboard so that way you don't damage structures, and send it off to a lab for diagnosis. There's also a difference between grass and sedges that we need to know. True grasses have rounded stems. Okay, if you pluck out a piece of Kentucky blue, look at that stem, it's going to be round. And the sheaths are open. Okay, but sedges are triangular. So if you get down there and you pluck a stem and you look at it long ways, you'll see that it's a triangle. And now you know it's a sedge. And the sheaths will be closed. Also, when we're identifying weeds can be confused by common names like couch grass, like quack grass. Those are both the same thing, common name, but people call it different things, right? So in our profession, it's ideal to use Latin names or scientific names when describing weeds. That way we know exactly what we're talking about. Now, it's very difficult to know all these Latin names, but I highly recommend that you at least, get a few under your belt. And that way you know exactly what someone's talking about. Okay, so this is actually supposed to be a picture of a weed. And we were supposed to dive into the weeds, but the software that we used didn't translate that well. So we're going to dive into the weeds and the weeds that we have here in Michigan. This is annual bluegrass, also known as Poa annua. It's an annual or a perennial. It reproduces through seeds, produces a large number of seed heads, and it doesn't really care about the mow height. It'll still produce a bunch of seeds. It grows really well in late winter and early spring and fall, but it can die back in hot weather. So again, this is a cool season. It likes the cool weather. This is common chickweed. I'm actually going to make this bigger so you guys can have a better picture of it. Common chickweed, also known as Stellaria media or media. It's a winter annual. It reproduces with seeds or creeping stems. Flowers can appear star-shaped. The leaf and stem may have hairs, and it has a trailing growth habit. So if we look at this, you can see how it's creating like a mat as it's growing out. Cerastium vulgatum. It's a perennial. It grows in a mat-like growth habit. It's got elliptical leaves that are covered with hairs, and you can see the hairs on those leaves. So it's a good indication that you're dealing with mouse ear chickweed. It reproduces through seeds, and it also roots at the nodes. The nodes would be where those leaves are. If that's touching soil, it can root out from there and continue to spread. The leaves are sticky, hairy. The mowing of it will stimulate its growth. It tolerates mowing height of putting greens. So this stuff, I mean, you could really, mow it down pretty heavy and it's still going to survive. This is white clover, Trifolium repens. It's a perennial. It reproduces through seeds and stolons. Stolons are underground. It has 3 leaflets that are joined together at the base without stalks. So if we look at those leaves, they're all joined at the stem. Okay. Another thing that's really kind of indicative of white clover is going to be that white kind of halo that you see there. This is large crabgrass, Digitaria sanguinalis. It's an annual. It reproduces through seeds. It's typically low growing with multiple upright stems. It's got prominent hairs covering the leaf surface, and the leaves are twice as wide as smooth crabgrass. This is smooth crabgrass. Digitaria iscamum. It's an annual. It reproduces through seeds, low growing with many upright stems. But you can see the difference between these two, right? Those have very, very large leaves, and these ones are much smaller. If you look at the stem point where those leaves are coming out of, it's much, much fatter and wider than these ones. Here's our good old dandelion, Taraxacum officinale. It's a perennial. It reproduces through seeds. You've all seen these. You know what they look like. They flower from April to June. It's got a milky substance inside of it, and it's got a pretty wicked taproot. This is ground ivy, otherwise known as creeping Charlie. Glaucoma heteracea. It's a perennial, reproduces by seeds and creeping stems. It also roots at the nodes. So if this thing's creeping, it does take over very, very quickly. This will take over a lawn very, very quickly. It's very, very aggressive. The stems are 4-sided, and they're generally found in damp, shaded soils. It does form a dense mat, and it creeps significantly across the lawn. This is henbit, Lamium amplexicale. It's a winter annual. It reproduces by seed. It's got round, hairy leaves with deep veins. The leaves have coarse tooth margins. They're arranged in opposite on square stems. This is prostrate knotweed, Polygonum aviculare. It's an annual. It reproduces by seed. The stems grow low to the ground, forming a mat. It develops thin, long taproot. It's indicative of compacted soils. It does not mind compacted soils, and it does well there. Late winter seedlings of this plant can be mistaken for desirable grasses. This is yellow nutsedge, Cyperus esculentus. It's a perennial, reproduces through seeds, tubers, or nutlets. Stems and leaves are yellow-green. Stems are upright and triangular. They have fibrous roots with tubers and nutlets. It prefers wet soils, and it's very, very difficult to control. Because of those nutlets. Basically, it makes it extremely difficult to control because of that. But you can see the difference in color here in that grass. So you can definitely tell what is yellow nutsedge and what it's not. It's got a very unique color in a lawn. This is a broadleaf plantain, Plantago major. It's a perennial, sometimes an annual. It reproduces through seeds. When mowed, the leaves lie flat on the ground. Stalks extend upwards. When it's not mowed, the leaves are more upright. So you'll see them, they're kind of praying to the sun. Also, you'll notice that their leaves are kind of twisty and curly. That's also another indicative way to identify them. But they're very easily identifiable due to the broad leaves at the base of the plant. This is buckhorn plantain, Plantago lanceolata. It's a perennial. It reproduces by seed and through root shoots. Again, just like the other plantain, when it's mowed, the leaves lie flat. The flower stalks extend upward. This one, the leaves are more narrow and dense, and the leaves curl or twist. The taproot's pretty strong, and that also has really strong laterals. This is quackgrass, Elytrigia repens. It's a perennial. Reproduces by seed and rhizomes. Rhizomes are extensive. They can spread from 2 to 8 inches, but they could also spread 2 to 6 feet depending on the soil conditions. That's primarily going to be whether or not you're in heavily compacted clay soils or sandy soils. If you're in sandy soils, those roots are going to run like crazy. If you're in heavily compacted clay soils, they're not going to run as much. They're going to be within that 2 to 8 inch spread. The stems are upright and they're branched at the crown. This is creeping speedwell, Veronica filiformis. It's a perennial, reproduces by seed, stems, root at the nodes. Leaves are similar to ground ivy, but smaller, and they're covered with hairs. It produces 4 petal purple pinkish flowers in the spring, and they're heart-shaped seeds. And I did want to step in here because, like we said earlier, right, weeds is a human designation. It's not a designation in nature or botany. If you look at these plants and how they were definitely landscaped this way, right? They're growing that way amongst the stones and the stone step walkway. That is a beautiful landscape. If you walked up to somebody and said, that is a weed, those are weeds, you have to kill them, they'd say you're crazy. So it's all situational. In this sense, this site, those are desirable, right? So you wouldn't tell somebody, hey, we need to kill all this because look at that, it looks beautiful. So in this sense, it's not a weed. It's a desired ground cover plant. And they did it very well. That looks awesome. So I just wanted to interject and say, not all weeds are weeds when they're used in certain situations or in nature, right? So just my little rant there. I wanted to include a picture to show you how some of these could be, desirable and look really nice. This is prostrate spurge, Euphorbia maculata. It's an annual, reproduces by seeds. The stems grow flat along the ground. They form a dense mat, and then they have branching stems that are hairy. The leaves have a purplish red spot in the center, and all parts contain a milky juice. Now, I'll also interject here, Euphorbia is actually a desired plant in greenhouses, and it's used in greenhouses, in planters, in hanging baskets, things like that. So Euphorbia in general is not a bad plant or a weed per se. It's all in how it's used. Again, that site and what the use purpose is. This is yellow wood sorrel, Oxalis stricta. It's normally a perennial, but sometimes it can be an annual, and it reproduces by seed. It has slender stems that are branched and roots at lower nodes. The stems covered with loose curly hairs, and they have really shallow roots. These things pull out really easily. Flowers can produce seed from early spring to late fall, and the leaves contain a sour juice. And if you look at those leaves, it's very similar looking to a clover plant. So you just have to know the difference between clover and yellow wood sorrel. This is common yarrow, Achillea millefolium. It's a perennial. It reproduces by seed and rhizomes. It's got fine, delicate, fern-like leaves, and it's aggressive, and it grows close to the soil. It tolerates low mowing height and compaction, and when crushed, it has a bitter taste and odor. Now, you'll notice on this one, I included 2 pictures because if you look at the picture on the left, that is what common yarrow looks like in a lawn setting. That's what you'll find. However, on the right, if you look at those white flowers, those were definitely planted and designed. You can see the mulch bed. Those are desirable plants in that sense. So from a pesticide applicator point of view, you might have common yarrow in a lawn and you can't get rid of it because somebody has it in their landscape beds. And it's something to tell them like, hey, this stuff's going to continuously be coming back because you have this planted here. It looks great in your garden, but just know that every year we're going to have to be battling it in your lawn. Okay. So let's talk about managing some turf weeds. All right, some things that we need to know about turf is that it experiences a lot of injury. We have insects, diseases, fertilizer abuse, pesticides, excessive wear, traffic, poor mowing practice, poor cultural practices, over irrigation and under irrigation. There's a lot of stress factors that can happen on turf stands. The number one rule is that a healthy, dense turf stand is less likely to allow weeds to take hold. If you can have a healthy, dense turf stand, you'll be much better off than if you're mowing it at a lower height. If weeds are present, we need to coordinate weed control activities that must take place. And those activities must take place when it's the most susceptible stage for successful weed management. So we're going to talk about the strategies here. Okay. There's 5 strategies to manage weeds in turf grass. Again, number 1 is maintain a vigorous turf stand. Number 2 would be to prevent seed production. Number 3 would be prevent seed germination. Number 4 would be limit emerged weeds as seedlings. And number 5 would be to control developed weed plants at susceptible stages. Okay, so let's talk about maintaining vigorous turf stands. This is by far the most important step. If you have clients that are mowing their lawns at 1 inch or 2 inch, they're always going to have weeds in their lawn, no matter what you do. And, they need to accept that. And if they think that you're doing a bad job, tell them, no, we need a vigorous turf stand. You need to up the mowing height. Mowing should be performed at the highest preferred setting. Me personally, on my lawn, I mow at probably 3.5 to 4 inches here in Michigan. I prefer 4. When I see 4, my turf is much healthier. It can withstand drought better. It's a much more lush green, right? Most people prefer in between like 3 to 4 inches. And that's good, right? It creates a dense turf stand. You want to perform dethatching and core aerations. When weed seeds are not germinating, fertilize when turf is actively growing to avoid stimulation of weed germination. And you also want to apply water to match evapotranspiration rates during hot, dry periods. So we definitely need to water our lawns when a bunch of water is being evaporated into the air and when they're consuming a lot of water. But if you have a diseased lawn, you want to water diseased lawns very lightly in the afternoon every dry day. And again, that's just to make them a little bit healthier, not give the fungal diseases the moisture and humidity that they need. So yeah, we just want to target basically when the plants actually need that water. So let's talk about number 2, preventing seed production. Weeds can produce a tremendous amount of seeds. We talked about that earlier, right? This is another great example. A purslane plant can produce 2 million seeds in a single season. 2 million seeds. Holy cow. So you got purslane. Well, you're probably going to have purslane for a long time if you don't control the seed production. But we want to eliminate the weeds before they reach seed production so we can stop 2 million seeds from, being produced and out there in the turf stand. And you also want to be aware of introducing weed seed infested compost, mulches, topsoil, or grass seed. This happens pretty frequently. I can comment that, again, my profession is mainly managing poison ivy on residential properties. And people have gotten mulch, or they've gotten, truckloads from chip drop, which is a common thing that tree companies do to drop off chips for free instead of paying to dump them. And they get mulch that's filled with poison ivy seeds. And I get called out and said, yeah, it probably came in the mulch, So it definitely something to be aware of. All right. So preventing seed germination. We need to understand that it's impossible to eradicate weed seeds in the urban landscape. Studies show that if you dig down 6 inches in soil, it's estimated that there's about 2,000 seeds per cubic foot in the soil. That's a lot. So we're never going to get rid of them. We just have to manage them. One of the best ways to manage them, again, is with a dense turf stand at mowing at 3 inches or more. Those seeds require sunlight to germinate. And a dense turf stand is going to prevent the light from getting down to those seeds. You also don't want to disturb the soil deeper than 2 inches because you can cause these seeds to come to the surface and germinate. Also, if you do have germinating seeds, you can suppress them with pre-emergent herbicides, and we'll talk about that a little bit more later. Number 4, limiting the emerged weeds as seedlings. Every single weed out there is susceptible to manage when it's young and fragile, right? Smaller plants are very easily removed by hand, and seedlings can easily be injured by herbicides. Herbicides are most ideal during vigorous growth stages. And so herbicides are not necessarily the best thing to deal with seedlings. It really depends. It depends if they have enough leaf surface for enough herbicide to get on them to kill them down to the root. If they don't, it's not going to have the right effect. It's going to stunt them. It's going to alter them. And it's probably going to make them more difficult to kill with herbicides. It'll make them mutate. Even in my practice, right, I deal with poison ivy. If I'm going to a client's house to kill poison ivy and I see seedlings, I hand pull them. There's no point in me applying a chemical to kill these when I could very easily pull them out by hand. And of course, I'm wearing gloves. I'm not out there barehanding poison ivy. Number 5, control developed weeds at susceptible stages. Managing developed weeds is more difficult than when they are seedlings. And I would argue with this in a certain extent. If you're talking about hand pulling weeds, then yes, mature weeds are more difficult to manage. If you're talking about chemical applications are relatively easy and not very laborious, depending on how you're doing it. But, seedlings, hey, if you got to pull them out, you got to pull them out. The timing is critical. It's ideal when weeds have depleted food reserves or are physically weakened. For instance, perennials are weakest from bud to the bloom stage, so that's a really good time to target them. Repeated cutting of perennials and biennials forces them to produce new growth, which stresses them out. It's also going to deplete them of their food reserves, right? Because they're storing food reserves down in their root systems for the following year. And so if you can continuously deplete them of those food reserves, you'll eventually kill them out through a mechanical practice. Without the use of herbicides, turf stands will not be free of weeds. I feel bad for all the people that are anti-pesticides and anti-herbicides because they're going to have weeds in their lawn. So let's talk about using herbicides. Numerous herbicides are marketed for turf weed management. And just know that depending on what herbicide it is, the plants, the soil, and weather conditions all influence the herbicide action. Also, you have to remember that the label is the law. Whatever that label says, the rates, the plants that it targets, the sites that it's used for, that's what it is. You cannot really deviate unless you apply for, some sort of permit to do that, a special use permit or research or things like that. So you have to apply it according to the label. The turf can be injured from herbicides if it's stressed or weakened. So if you have a weakened, stressed turf and you're out there doing an herbicide application, you could damage that turf even more, right? Just like we were talking about the stresses of turf that we're dealing with, pesticide applications are definitely one of them. Herbicides can be classified in many ways. Here's 3 ways that herbicides are classified. We have pre-emergent versus post-emergent, contact versus systemic, and selective versus non-selective. So let's talk about pre-emergent herbicides. They're applied before the weeds are visible, which means before they are emerging from the soil, right? So plant growth can be occurring underground, but the moment that it germinates, it's going to come into contact with that pre-emergent herbicide. Most pre-emergent herbicides work in the way of a vapor barrier. So you apply a pre-emergent, it's going to create a vapor barrier. When those seeds germinate, they germinate and their leaves go into that vapor barrier and they die. They do need to be incorporated into soil surface with water. That can be either irrigation or rainfall. And they are persistent, right? Persistence describes the amount of time that an herbicide remains active in the environment. Pre-emergent herbicides are persistent and can provide 6 to 10 weeks of control. So they are going to be in the environment for quite some time, which is nice in one aspect. And the other aspect is not so nice because, now we have herbicides in our environments. Generally, seeding with grass seed, I put that in there because it doesn't say that in the book, but that's what it means, needs to be delayed for several weeks after applying pre-emergent herbicides. That's because, if those seeds germinate and they hit that vapor barrier, they're likely going to die or be damaged. So let's talk about post-emergent herbicides. Post-emergent herbicides are applied to existing plants already emerged from the soil. The uptake of a post-emergent herbicide is generally through leaves. However, it can be through roots and shoots. And it also depends, right? If we're talking about, woody plants, you can use herbicides and penetrants, and you can apply them to the trunks of trees. The penetrant is like an oil base, so it allows that herbicide to penetrate through the bark into the cambium layer and kill it. For broadleaf weeds, though, and grasses and sedges, it's primarily going to be a foliar application, and you're going to spray the leaves. Post-emergent herbicides generally do not remain active after application, and they do not provide a residual control. So it's always good to note that just because you apply it doesn't mean that it's going to kill things after that. kill things after the fact, right? Whatever you spray, it's going to kill, but it's not going to, kill things as they emerge. That's why we have pre-emergent herbicides. Another way to split up herbicides is contact herbicides versus systemic herbicides. Contact herbicides are very effective on annual and biennial weeds. As a note, as it sounds, contact herbicides only kill what they come into contact with, and specifically that part of the plant. You could spray one side of a plant with a contact herbicide, and that side dies, but the other side lives. Now, systemic herbicides will move throughout the whole plant system, right? So you spray a certain area of the plant, it's going to translocate throughout the rest of the plant system and kill it even underground. It's going to kill the roots. These are more ideal for your perennials. I think most of us out there in the turfgrass world are using systemic herbicides and like 2,4-D, things like that. They're killing the system underground as well. We also have selective herbicides and non-selective herbicides. Selective herbicides will control some plants, but not others. Most common reason for a selective herbicide application is to kill or remove broadleafed weeds from a turf stand. Like I said, 2,4-D, triclopyr, there's a lot of them. Now, graminicides are grass herbicides. These remove grasses from broadleaf plants. So if you have a garden bed that has broadleaves and you just want to kill the grasses, you would want to look for a product that's a graminicide. And of course, you always want to check the label for susceptibility, right? Most selective herbicides are still going to have the potential to damage ornamentals. Also, you need to check the volatility of those products because you could spray it, it'd be fine, but if it volatilizes, it could still damage ornamentals. So we have to be cautious of that. Non-selective herbicides kill or injure all plants. They are not selective. They will damage whatever they touch. You should use caution around desired ornamentals or desirable plants. And these are often used for full renovation work, edges along fences, driveways, sidewalks, and tree skirts. If you are to apply herbicides, this is a different note. If you are to apply herbicides around trees, the most ideal herbicide that you can do if you want to create like a tree skirt or if you're applying in mulch beds is going to be glyphosate. Why that is because once glyphosate comes into contact with soil, it's no longer active and it's bound to that soil. Whereas other herbicides like triclopyr, like 2,4-D, they can leach through, they can get into the root systems, they can volatilize, and they can damage ornamentals. So let's talk about herbicide action and weed plant characteristics. Biological and physical characteristics of weeds have often influenced effectiveness of herbicides. So what are growing points? Growing points are sheaved or located below surface, unaffected by contact herbicides, right? You can't really spray a contact herbicide on the roots. It's just not going to happen. Same thing with rhizomes. You're not going to be able to get those underground with a contact herbicide. Leaf shape also influences how herbicides work. Herbicides tend to bounce off or run off narrow upright leaves, but broad flat leaves tend to hold herbicides longer. Wax and cuticles, foliar sprays have a hard time penetrating waxy cuticle layers. There's also leaf hairs. If you have plants with really dense leaf hairs, it prevents herbicides from touching that leaf surface. And then there's deactivation. Some plants can deactivate herbicides. How wild is that, right? They just have this ability to deactivate an herbicide. Crazy. But it makes them less susceptible to chemical injury, obviously. And then we have life cycles, right? Seedlings are the most vulnerable to management practices. Plants in vigorous growth state are most susceptible to systemic herbicides or herbicides in general. And mature plants are least damaged by herbicides because they're not moving nutrients or water. It makes it really, really difficult when there's no movement in the plant to kill them. Now, I do want to jump in here. As far as like waxy and cuticles, things like that, they do have penetrants. They do have things that can help you, get that herbicide down to where you need to go. So definitely look into your various surfactants that you can buy and adjuvants. Leaf hair, same thing. Leaf shape, same thing. You could get stickers, you could get spreaders to add into your spray that make it more effective. So let's talk about herbicide action and weather. Okay, the level of weed control depends on the weather. when you're applying herbicides. Too much soil moisture may reduce herbicide availability to plant roots. Interesting, right? Heavy rain can cause leaching or runoff. Makes sense. If there's herbicide laying on those plants and a heavy rain comes, it's going whatever's not absorbed is going to wash off and run into the ground, penetrate down through the ground, or run off into surface waters. Light rains can be beneficial for root absorbed herbicides, so it carries it down to the root, right? Temperature, light, and humidity affect herbicide action and potential for volatility. This is how off-target damage occurs on ornamentals. If you have temperature inversions or super high temperatures and that chemical starts to become in a gaseous state, it will become volatile. It will start to damage ornamentals. Herbicide products can vary in the risk of volatilization, so you should always follow the label directions and the recommendations of the manufacturer. And also check the weather and humidity and temperature. Be smart about it. I think this might be our last slide. All right, so how do we correct herbicide application mistakes? Many herbicides, this is a really good note to have, and definitely you want to take note of this. Many herbicides can be deactivated with activated charcoal. So you should always keep some of that in your truck just in case you have a spill or something like that. You want to check with the manufacturers and distributors for rates and procedures in case certain things happen. In the event of a large mistake, you may need to remove valuable turf or ornamental plants to prevent their injury or death. And that could result in a lawsuit and your liability, right? It's your license. You become liable if you make those mistakes, and you could result in a lawsuit. If you have an accident with an herbicide and you kill a $30,000 landscape, say you apply the wrong herbicide, say you apply imazapyr to kill some weeds in a garden bed, yeah, you're probably going to have to pay for that. So we definitely want to do whatever we can to prevent injury and be smart and make sense of it all. And don't make those mistakes, okay? All right, so that is chapter 6 in a nutshell. It was really dense, right? We're almost at 45 minutes right now. Super dense chapter, lots of information there. And, it's one of those where this is important. You're going to be asked questions on plants, how to identify them, what they are. They're probably going to have pictures saying, what is this? They want you to know that you know what you're doing and you know what you're talking about to be licensed. So other than that, that's chapter 6. Hope you guys are doing well. Hope this helps you. Hope this serves you. I'm going to get chapter 7 and 8 out next week. Yeah, that should do it. So without further ado, take care and God bless.